Okay, we will start our lesson today with Al-Fatihah. Okay, so can you see me now?
Yes, Doctor.
Okay, wait. Okay. So, good day everyone. In this class, you are group what? G. Is it group G?
Yeah, madam. Group G.
Okay. Okay. Actually, I have activate your attendance list in the U future. Okay, you can check your U future and tick your attendance, please. Okay, so are you ready to start our course today? Are you ready? Before that,
Yes, Doctor.
I want you to scan this one first before we start. Okay, actually I want you to participate in some of the activity in our lecture today. So please scan the QR code first. Wait, I need to change new class. Maybe this is the previous class. Wait, Okay, now please scan again the QR code. Okay, I can see Badrul, Yusrizal, Farah, Fathul. Okay, lagi Laina, Najwa, Izwan, Mashita. Lagi? Zulaika, Elgo Sheila, Syafiqah, Mimi, Nabila. Any more? Zarif, Aina. Okay, we should have about 20 something. Okay. Okay, please join the rest. Okay. Okay, I hope the rest will join later. Okay, so have you watched the two videos uploaded in the YouTube? One is for the OBE implementation and another one for the lesson plan.
Yes, Doctor.
Dah, doktor.
Okay, so how many topics actually in this course?
3.
3.
3 topics. Okay, and are you ready to start? Bersemangat tak ni nak start ni? This new subject ni. This is the last structural analysis subject, structural analysis course. Okay, because next semester you will take design course. Okay, this is actually the last structural analysis course. So actually along the syllabus you have solid mechanic and then solid mechanic, then determinate structure, and this is the last one. Okay, and of course in order to success in this course you should be able to master what have you learned previously under solid mechanic as well as determinate structure. Okay, so before we start okay, we will do this activity first. Okay, I want to ask you, please respond. What do you see yourself doing in this course along this semester? Okay, what do you see yourself doing in this course along this semester? Okay, I will start the activity right now, so please respond. Okay, so everyone, please respond. Boleh tak? Tak ada yang cuba respon?
Doktor, apa soalan dia tadi? Tak tu tadi.
Cuba respon, use your dekat phone tu kan, kalau pakai phone kan only use one gadget, so you just swipe to another window. Okay, the question is, okay, what do you see yourself doing in this course along this semester? Okay, just throw what in your idea. Okay, what do you see yourself doing this course along this semester? Of course, you have said something. You have asked maybe your senior about this course. So, what is actually your hope for this semester, along this semester? Okay, Only one response? I need more than one. Come. Respond. Okay. Other than this? Okay, learning new things. Of course, you will learn something. You will learn indeterminate structure. So what else? A lot of calculation. So what do you see yourself doing this semester? Are you happy or not happy? I hope this subject will be going smooth. Okay. Any more? Learn some calculation on structural analysis. Going to have a great experience. Okay, lagi. Any hope? About your hope, about your, okay. Of course, it will have a lot of calculation, but inshallah will be going smooth. Okay, anything? Baru 7 orang response. Okay, nanti ada lagi soalan, so please respond. Get ready for the next activity. Okay, I will close this response right now. Okay, so inshallah it will be good if actually you have understand, especially what have you learned previously, beam analysis in solid mechanic. So this will be the continuation of that. And of course, what have you learned previously under determinate structure, like frame analysis, truss analysis. So of course we will analyze again, because structural analysis itself will cover all this type of structure in order to analyze reactions, internal forces, as well as deflection or displacement. Okay. Okay, thank you for the response. So we move to next. Okay, so this is just a refreshment of what you have learned previously in the determinate structure course. This is actually the prerequisite course. Actually, this one I have asked the class this morning, group F. Okay, group F. So type of determinate structure you have learned previously. Can anybody tell me? Type of structure that have you learned previously under CES 424? Do you still remember?
Simply supported beam.
Simply supported beam. Okay, right. Okay, any other answer?
Frame.
Frame, correct. Lagi?
Cantilever beams.
Cantilever beam.
Cantilever beam. Okay, any other answer?
Ash.
Arch, trusses,
Cable.
cable. Any more? Okay, so these are some of the answer given by your friend, okay, this morning. Okay, so we have actually learned on how to analyze beam, frame, truss, okay, arch, cable, okay, and all these are actually determinate is actually type of structure. And in previous course in CS 424 as well as CS 422, you have actually learned how to analyze reactions, internal forces, as well as displacement for determinate structure. And now we are going to look at to the continuation of that, which is called as indeterminate structure. And for indeterminate structure, we will inshallah cover beam, frame, truss. Okay, and we don't cover actually cable and arch in this course, in this subject. Okay, so we move to next one. Okay, so this I want you to respond to this question, to this refreshment. Okay, since you have learned structural analysis, you have actually passed solid mechanics as well as determinate structure. Do you remember some of the topic that you have learned? What I mean is some of the topic or method that you have learned previously. Okay, some of the method or topic. Okay, because some of the topic for the previous course, some of the chapter or topic is actually based on type of structure. Some maybe based on the method. Okay, the method itself. So just name it. Okay, name the topics you have learned in previous courses. Okay, I need your response. Okay, good. Moment area method in CS424. Moment distribution method. Moment distribution method is actually topic number 3 in this course. Buckling of column, okay. Critical P. Method of join, okay, under truss. Okay, other than that, method of section. Okay, join method and section method, correct. Okay, virtual work method as well as influence line. Okay, any more? Okay, good. Virtual work method to analyze displacement or deflection. Okay, moment area method also one of the method to calculate deflection. Okay, moment of inertia. Moment of inertia. Okay, we use moment of inertia in order to analyze deflection. Okay, other than this, any more? Okay, enough. Okay, okay. That's all for this one. The rest, okay, can respond to the next activity. Okay, I want to close this submission now. Okay, so shear force and bending moment. Shear force and bending moment in CS422 solid mechanics, you have learned how to write the shear equation and then write the moment equation in order to draw the shear force diagram and bending moment diagram. And of course, this will be the writing the moment equation will be the things that you will need to do under the first topic called flexibility method. Okay, method of section, method of joint is actually methods to analyze the member forces in the truss. And under the flexibility method, when we analyze truss later on, of course, we will need to do again method of joint. Actually, we just need to have one from the two methods in order to identify the member forces for the truss. Okay, moment distribution method, as I mentioned just now, is actually one of the chapter in this course. Okay, maybe you who come from diploma intake have actually learned this in diploma. in diploma. Okay, moment error method is one of the method to calculate deflection, and actually in this course we will not repeat it again. Okay, buckling of column. Buckling of column, you have learned how to calculate the critical P, P critical, where under the buckling of column you have learned about the effective length. Effective length of the column actually can be implemented to all to beam as well. The effective length between two supports. Okay, between two supports. Okay, and influence line as well. Okay, so next, okay, we move to next one. If you have question, you may interrupt, you may ask at any time. Okay, we move to the learning outcome. So this is chapter number 1, flexibility method. Okay, and in this topic number 1, at the end of this chapter, you should be able to, number 1, calculate degree of indeterminacy. Okay, calculate degree of indeterminacy and identify redundant. Actually, you have learned how to calculate degree of indeterminacy, right? But at that time previously, when you learn determinate structure, means that you calculate degree of indeterminacy where the value is equivalent to, for determinate structure, the value is equivalent to, you still remember, DOI. When do you learn degree of indeterminacy? This degree of indeterminacy? Dah belajar belum degree of indeterminacy?
Dah, Doktor.
Okay, for determinate structure, what is the value of DOI that you have learned previously? For determinate structure.
0.
Okay, determinate structure, degree of indeterminacy is equal to 0. Okay, of course, you use the formula, right? The formula to calculate degree of indeterminacy for beam, frame, as well as truss. Okay, so in this course, you need to have or to use back this knowledge in order to identify whether the structure is determinate or indeterminate. Okay, so degree of indeterminacy, whenever okay it is more than 0, it is called as indeterminate structure. Indeterminate structure. Okay, and actually the degree of indeterminacy is actually representing redundant in the system. Redundant in the system. Okay, so I want you to try to understand, okay, what is actually redundant. Okay, of course, the value will be depend on the number of degree of indeterminacy, and actually we will focus topic number 1. We will focus on redundant up to 1, 2, and 3 only. Okay, degree of indeterminacy, limit lah, limit for flexibility method, analysis of beam, frame, and truss. For flexibility method, we need to limit up to 3 degree of indeterminacy, because whenever the degree of indeterminacy more than 3, we cannot calculate the redundant value using manual calculation. Okay, so there is a limit that you need to know. Okay, limit DOI. The limit is degree of indeterminacy, limit to 3. Okay, limit to 3, because this redundant, we will determine redundant value, we will determine using equilibrium equation, and we can only determine use up to 3 because we will solve using simultaneous equation. And if more than that, we will move to stiffness method. Okay, the next chapter. Okay, okay, learning outcomes number 2. Draw diagrams. Draw diagrams for primary and redundant structure. Okay. So after after understand on the degree of indeterminacy as well as redundant, okay, we need to the redundant actually need to remove from the system. Redundant, okay, that redundant that we have to determine is actually to be removed from the system, and we need to draw the diagram after that. So the diagram after removing redundant is called as primary structure. Here the primary structure as well as redundant structure. It means that step number one, identify redundant. Okay, and then what we need to do with redundant, we have to remove redundant. And the structure after removing redundant is called as primary structure, and we need to be able to draw the diagram. Draw the diagram of primary structure, and after that, the other diagram that you need to understand is the redundant structure. Okay, and you must be able to draw each of these structure. Okay, next one is calculate displacement in primary and redundant structure. Means that calculate displacement in the structures. Calculate displacement in the structures. Primary and redundant structure ni is actually determinate structure after removing redundant from the system. Okay, we will be getting, of course, indeterminate structure. We identify redundant in order to determine the value of redundant, and we need to remove the redundant. And the structure after removing redundant is actually both are determinate structure, and determinate structure we can calculate the displacement. Okay, displacement. And along the way, start from solid mechanic as well as determinate structure. What have you learned? Actually, the summary of what you have learned is actually analysis of determinate structure. And actually, can you tell me the summary of what actually you have learned under solid mechanic as well as determinate structure? The aim actually, or the summary. So all the methods you mentioned just now is actually to find the final goal. So and in structural analysis, okay, in structural analysis, whether it is determinate structure or it is indeterminate structure, what we actually calculate is only three things. So what are these three things? What are these three things? The objective to analyze analyze structure. What have you calculate actually along the way, and start from analysis of beam, and then analysis of frame, and then analysis of truss? You are actually calculating what?
Shear force.
Okay, shear force. Lagi? Any more?
Reaction.
Okay, reaction. Okay. Other than that,
Moment.
reaction is correct. Okay, number one, reaction is correct. Actually, shear force is also correct. Shear force is also correct. Lagi? Actually, only three. The answer is three only.
Bending moment.
Bending moment, okay. Okay, some said reaction. Some said reaction. Bending moment. Bending moment. Okay, some said shear force. Other than this,
Internal force, Doctor.
internal force. Internal force. Other than this, summary of what you have learned. Start from solid mechanics, you learn beam analysis. Under beam, what have you actually done? Under beam. Beam in solid mechanics. Under beam topic tu, okay, under beam topic, you have actually calculating what? Do you still remember? Beam. Under solid mechanics. Under CES 422. Under beam topic. Cepat, just throw the idea. Beam, beam, beam in analysis of beam in solid mechanics, you learn how to calculate reaction, right?
Ya, Doctor.
Okay, reaction. Okay, and then you learn how to write the shear force and shear equation and moment equation in order to draw shear force and bending moment. And these two is actually called as internal forces. Internal forces. So under beam analysis in solid mechanics, you have actually learned one is how to calculate reaction, and two, you have determined, you have actually learned how to analyze internal forces. Isn't it?
Yes, Doctor.
Okay, so continue beam. Do you have a beam topic in the determinate structure course? Did you analyze beam in last semester?
Yes.
Okay, what have you learned? What have you learned? Okay, beam in solid mechanics, you learn how to analyze reaction using equilibrium equation, and then you learn how to write shear equation as well as moment equation in order to determine or draw in order to draw the bending moment diagram. This shear force and bending moment diagram is actually internal forces in beams. Okay, then in CS424, there is a continuation of beam analysis under one topic. So what has you learned actually? You don't remember? As a civil engineering student, when you take structural analysis subject, so whenever anybody asks you what have you learned in structural analysis, there are actually three words to represent structural analysis. Okay, these three words to represent structural analysis, okay, have been stated 1 and 2 here. Reaction and internal forces. So whenever somebody ask you what have actually you learned under structural analysis. Okay, the first answer is I learned how to calculate reaction in structures. That is the answer. Means that start from semester 2, you learn solid mechanics and then followed by determinate structure. What have you learned? You have learned how to calculate reactions and internal forces. Isn't it? Ada buat tak these two things?
Ada.
Ada doktor.
Okay, you should be able at the end of this structural analysis courses this semester, you should be able to summary what have you learned actually in structural analysis course. In simple word means that you understand what it's all about. If you cannot explain it simply, it means that you don't understand it well enough. Okay, tell me what have you learned besides analysis of beam calculating reaction and then determine internal forces using shear equation and moment equation in moment equation in order to draw the shear force diagram and bending moment diagram. And there is another one, analysis of beam. Okay, analysis of beam. Last semester you have learned this last semester.
Doktor, kalau displacement, betul?
Yes, it is displacement. 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 So this is actually the things that you have learned under the structural analysis. Regardless whatever type of structure that you what type of structure, okay, if it is truss, you need to calculate reaction as well using equilibrium equation, right?
Yes, doktor.
And then in truss, you have learned how to calculate member forces using method of section and method of joint. Method of joint and method of section that you use, okay, that you have learned is actually, okay, to calculate the member forces, and member forces in the truss is actually the internal forces. Okay, internal forces. And then last one is actually displacement. You learn how to calculate displacement using method of virtual work. How to calculate deflection using method of virtual work, you need to know the internal forces. In order to calculate displacement in beams, you need to integrate the moment equation. Where is the moment equation comes? It actually comes from the moment equation, because the bending moment is internal forces. Okay, so the moment equation, in order to calculate in order to calculate displacement, you need to understand how to write the moment equation. The moment equation tu is part of internal forces under the bending moment tu. Same goes to truss. You learn how to determine reaction in truss using equilibrium equation, and after that, use method of joint or method of section to calculate the member forces. All the member forces in the truss system is actually internal forces. And in order to determine deflection in the truss, you need to have the member forces. Because when you cannot determine the member forces in the truss, you cannot determine displacement. Ada tak you perasan benda ni? Dalam virtual work method, you nak calculate truss. Dalam virtual work method, you nak calculate truss. Formula itself, you have to have member forces in real system, member forces in virtual system. Same goes to beam. The moment equation in real system, the moment equation in the virtual system. So all these actually the steps In order to calculate displacement, you need to calculate internal forces. In order to have internal forces, you have to have reaction. Without reaction, you cannot calculate internal forces. Without internal forces, you cannot calculate displacement. So what should you conclude? So what should you conclude? What should you conclude? Three semester, you learn structural analysis course. You should be able to conclude in simple word. So, okay, if anybody asks you, what have you learned in structural analysis? In simple word, 3 things that you have learned. What is it? What is it? Kena buka buku lama balik ni. What is it? Apa tadi? Class, please respond. 3 goals whenever you learn structural analysis. 3 goals whenever you learn structural analysis. What is it?
Safety factor.
No. 3 goals whenever you learn structural analysis is to determine number 1, reaction. Number 2, internal forces. Reaction, when you learn cable, you have to calculate reaction. When you learn ash, you have to calculate reaction. When you learn frame, you have to calculate reaction, isn't it?
Yes. Yes, Doctor.
And then followed by internal forces. How to calculate internal forces? Whenever you have calculate reaction. Without reaction, you cannot determine internal forces. If you are asked to calculate internal forces, you have to start with calculating reactions. And the third one is displacement. Displacement. The third one is displacement. Means that this is the flow. This is actually what have you learned until the end of structural analysis courses. These are all that you have learned. In simple word, displacement. So to calculate reaction, to calculate internal forces, you need reaction. To calculate displacement, you need internal force. Okay? Is it okay?
Okay.
Okay, Doctor.
Kalau tak okay, please relook at whatever you have learned previously. These are all is very, very important. Without this understanding, without this knowledge, you cannot success in flexibility method. Because flexibility method depend on this, all this. Okay? Okay, we move to the introduction. So flexibility method is actually one of the method to analyze indeterminate structures. So actually flexibility method ni will be take place whenever you cannot calculate reaction using equilibrium equation, because under the previous topic, it is determinate structure. Determinate structure, degree of indeterminacy is equivalent to 0. Degree of indeterminacy when it is equivalent to 0 means for beam and frame, number of unknown reaction is equivalent to number of equilibrium equation. That is why it is equal to 0. Okay, in simple way, we calculate the degree of indeterminacy by finding the difference between number of unknown reaction and three equilibrium equation. Three equilibrium equation. And then for thrust, of course, you need to consider as well the member forces in order to identify the degree of indeterminacy. It is M plus R minus 2J, the formula to calculate degree of indeterminacy for thrust. Okay, so flexibility method is one of the method, and it is actually take place whenever reaction cannot be determined. Cannot be determined because of number of unknown reaction exceed 3. Okay, exceed 3. Okay, so a structure of any type is classified as statically indeterminate when the number of unknown reaction or internal forces. Kat sini ada mention unknown reaction or internal forces. For beam and frame, we just need to consider the number of unknown reaction by identify number of unknown reaction from the support system. Okay, and then we minus with three equilibrium equation. So whenever it is equal to 0 means it is determinate structure. But whenever the structure has more than 3 unknown reaction, which is come from support, so the structure is actually indeterminate structure. Okay, and in order to calculate the degree of indeterminacy for thrust, we need to consider internal forces as well. Okay, so this method is also called as force method. Okay, force method kejap eh. Okay, flexibility method is one of the several technique available. So not only this method, so of course stiffness method as well as moment distribution method are the other techniques in order to analyze indeterminate structure. But the flexibility method is only takes place whenever we cannot determine the reaction using equilibrium equation. Okay, flexibility method involve removing enough restraint from indeterminate structure to render it statically determinate, and this determinate structure must be statically stable. So the idea is whenever we have, for example, beam like this. Okay, a number of unknown reaction is 4 based on the support condition, and this 4 cannot be determined using 3 equilibrium equation, so it is equivalent to 1. So this is actually degree of indeterminacy, and 1 here representing redundant in the system or constraint that need to be removed from the system. We have to remove 1 from the system in order to get the stable and determinate condition. That is the main idea. Okay, so this is just the review on the diagram look like. So the real world and idealized one. Okay, so this is simply supported beam. Okay, these are actually support connection the real one. Okay, number one is pin supported and then fixed supported, how it look like in the real condition. Okay, roller supported as well as fixed supported. Okay. Okay, next is activity statically determinate and indeterminate structure. The question is, in simple word, the difference between these two terms are. Okay, again, in simple word, difference between these two terms, determinate structure and indeterminate structure. What have you understand about the difference between these two terms? Okay, please respond. Okay, what is the difference between determinate and indeterminate structure? After 1 hour class. Okay, number of degree of indeterminacy. Any other answer? Okay, any other answer? Other than this answer. There's so many answer actually to explain or to differentiate between determinate structure and indeterminate structure. Other than degree of indeterminacy or degree of indeterminacy in other words. Okay, for determinate structure, we use equilibrium equation, correct? For determinate structure, we use equilibrium equation because number of unknown reaction equal to 3 equilibrium equation. Other than this, ramai ni 23 orang, mana lagi jawapan? Okay, lagi. Indeterminate structure have unknown reaction, more than 3 unknown reaction. Okay, using equilibrium equation, indeterminate structure, reaction more than 3, yes. Okay, other than this, depend on material properties. Okay, ada lagi? Jawab je. This is the time you okay, you nak test your understanding. Okay, bending moment. Bending moment ni, whether it is determinate or indeterminate, we should be able to draw actually. So, and of course, at the end of analysis means that whenever we analyze beam, after we get all the reaction, we should be able to draw the bending moment diagram for indeterminate beams. Okay, ada lagi? 6 orang je? Okay, 10 submission saya close. I'm waiting until 10. Okay, other than this answer. Apa lagi? When we talk about this determinate structure, what actually you can imagine about determinate structure or indeterminate structure? Okay, 7. Cepat, tak ada idea ke ni? Distribute load. Okay. Other than this, salah pun tak kenapa pun. Okay, just throw the idea. Just throw the idea. Anything else to differentiate between determinate structure and indeterminate structure? Cepat, cukupkan 10. Tak cukup 10, saya tak nak continue. Cepat, cukupkan 10. Cepat, you bukan duduk dalam kelas depan dengan saya, tak sempat nak Google cari jawapan apa semua kan? Cepat. Any more? Dah 5 minit dah ni. Any more answer? 23 in the class. Okay, 8. You can also repeat the same answer but in your own words. Doesn't matter. Any more answer? 9. There is actually so many difference that you can write regarding determinate structure and indeterminate structure. So many things to write. And you can only answer more than one. Okay. So kena prepare lah ya. Before masuk kelas tu please prepare mentally and physically. Mentally. Okay. Tak naklah tak respon macam ni. So please respond for whatever question. Okay, actually there will be more. Okay, means that this actually will reflect your understanding. Sebenarnya you dah belajar beam analysis, you dah belajar frame truss analysis. So boleh tak nak differentiate the determinate structure and indeterminate structure? You give the meaning what you have understand for determinate structure pun dah okay. Okay. So determinate structure can use statics to determine reaction. Static means the three equilibrium equation. Calculate reaction and internal forces. And for indeterminate structure, static alone are not enough. Statics alone are not enough to find reaction. That is why flexibility method takes place. Whenever we cannot determine reaction using equilibrium equation, we need to apply flexibility method. So how to apply flexibility method? By identifying redundant and soft redundant value. Okay. To analyze an indeterminate structure, we need to have additional equation. In order to analyze indeterminate structure, we have to have additional equation considering geometry of the deflected shape. Okay, considering geometry of the deflected shape. Okay, it will relate with all these reaction, internal forces as well as displacement. So deflected shape relates with displacement. Okay, so next Okay, what is actually benefit of having indeterminate structure? Okay, number one. Okay, generally indeterminate structure are stiffer than determinate structure. Stiffer than determinate structure. So whenever we have stiffer structure, we have less deformation. So by looking at the graph, okay, this is a P force displacement. Force displacement, we can see that for line of indeterminate, whenever P is increased, okay, the displacement will decrease. Okay, so the structure is more stiffer for indeterminate structure, and if the structure is stiffer, the displacement will be reduced. So this is one of the benefit of having indeterminate structure rather than determinate structure. Okay. Okay, next, the benefit of having indeterminate structure. Have a lighter and more rigid structure. So the stiffness, just now, the stiffer structure just now is also referred to the rigid condition of the structure, because when the structure is rigid or more rigid, of course, it will have less displacement. Okay, and with the added of redundancy in the structural system, there is an increase in the overall factor of safety. Okay, of course, when we compare between determinate structure and indeterminate structure, so indeterminate structure has more advantages compared to disadvantages. But of course, there are advantages as well. Okay, can you do you have the idea what is advantages of indeterminate structure beside advantages that I have explained to you just now? What do you think? Do you have any idea about this? Do you understand the meaning of the word stiffer? Stiff and rigid. Do you know the meaning of that?
Yes, betul.
Okay, whether okay, between stiff and flexible, do you understand the difference? Stiff and flexible?
Yes. Yes, betul.
Okay, do you understand when I said that in indeterminate structure, when the structure when the structure is rigid, it will have less displacement? Can you imagine that?
Yes. Yes.
Okay. Okay, so we refresh one more time. Okay, look at the diagram. Diagram number one, diagram A is actually simply supported beam, and simply supported beam is determinate beam. And diagram B is actually the continuous beam. Okay, and it is actually the an indeterminate beam. So the difference between these two diagrams, okay, is due to the support. Means that in indeterminate structure we have the structure with more support condition. Okay, so more support. So from the diagram, which one got lesser displacement? Okay, so please respond. Okay, mana lagi, mana lagi? lesser displacement. Okay. So I think yang choose A tu salah klik kot. Okay. So of course the answer is B. The answer is B because okay, I close the submission. Okay, if we refer back to the question, okay, diagram A is simply supported beam. Simply supported beam is determinate beam. Diagram B is indeterminate beam. And indeterminate beam, as I mentioned previously, okay, indeterminate beam are stiffer than determinate structure. So when the structure, when the structure is rigid, okay, the is rigid means that the displacement is lesser. Okay, so it should be B, yeah, it should be B. Okay, so this is the refreshment of the support characteristic. Okay, these are all type of support that actually you have learned previously. Okay, we have pin support, and pin support we have two constraint, which is come from horizontal and vertical direction. For roller support, only one vertical translation. Okay, fixed. For fixed support, the constraint come from horizontal and vertical, as well as rotation, and we also have internal hinge. Okay, and all this support, I believe you have already learned in solid mechanics as well as in determinate structure course. Okay, so in order to understand, or in order to analyze structures using flexibility method, actually we need to fulfill three condition or three principle. Okay, in order to solve for the redundant value, we need to satisfy, number one is equilibrium equation. Number two is compatibility. And compatibility principle or compatibility equation ni is actually come from the principle of superposition. And number three is this number two. Number three is force displacement. Force displacement equation. So along the way, in order to analyze, okay, the indeterminate structure, we need to gone through all this. Okay, we will analyze determinate structure, because the primary system and redundant system is actually we will solve it using equilibrium equation, because both of the diagrams are actually determinate structure, and then we have to fulfill compatibility equation, and compatibility equation is actually come from principle of superposition, and lastly we have to also apply the force displacement equation or principle, okay, in order to solve the analysis, the indeterminate structure analysis. Okay, next. Okay, these are actually the general procedure. There are, okay, I listed here 8 general procedure, but what I want to highlight actually is the two final procedure. Okay, so these two is actually our goal. Okay, these two is actually our goal. Means that you have to understand that when you learn flexibility method, you have to be able to see the final aim first. Okay, because degree of indeterminacy, choose redundant, so all these are actually the process. But we need to have the goal first, the aim first. So what is our aim is to calculate reaction, because this is actually the meaning of flexibility method. Flexibility method takes place whenever we cannot analyze reaction using equilibrium equation. So the goal for flexibility method is actually to calculate reaction. What is the goal is to calculate reaction. Okay, the goal is to calculate reaction. So this is actually the goal for flexibility method. We use flexibility method to calculate reaction whenever we cannot calculate using equilibrium equation due to number of unknown reaction exceed 3. Okay, means that we have to go for the aim first. Okay, and step number 8 tu, okay, procedure number 8, calculate remaining reaction here means these are 3 remaining reaction, because these 3 remaining reaction can be solved using equilibrium equation. Calculate remaining reaction means 3 unknown reaction which can be solved using equilibrium equation. Okay, so but before we can calculate equilibrium equation, we need to calculate the redundant first. We need to calculate redundant first. Redundant. So how many redundant will be depend on degree of indeterminacy. For example, if we have this beam with UDL, okay, by looking at the support, we draw the free body diagram. And from this, we know that there are 4 unknown reactions. It is AY, AX, and MA, as well as BY. Okay, there are 4 unknown reactions. So, and from these 4, only 3 can be determined using equilibrium equation. Only 3 can be determined using equilibrium equation. So, another one is called as the constraint. Another one is called as redundant. Another one is called as problem. So here redundant is actually the problem in the redundant. Okay, is actually the problem here. Why I said that redundant is the problem? Because if we know the redundant, we can solve the remaining 3 reactions using equilibrium equation. So we know that here we have the problem. So all the previous step, okay, all the previous step is actually to solve the value of redundant. So we will actually solve the redundant value by solving compatibility equation. Compatibility equation. Do you get what I mean? Okay, kita punya aim is to calculate reaction. Okay, kita punya aim is to calculate reaction. And how many reaction do we have for this beam? How many? How many reaction?
4.
4. Okay, these 4 unknown reaction, can we solve using equilibrium equation? Okay, can we solve this 4 using equilibrium equation?
Tak boleh.
Tak boleh. So sebab apa tak boleh?
Lebih daripada 3.
Okay, lebih daripada 3. So yang lebih tu we call it as?
Redundant.
Redundant. So here we have problem. The problem is redundant. So The problem is redundant. If we know the value of redundant, can we solve the remaining reaction? Kita ada 4 value here. We have AY, AX, MA as well as BY. Yang inilah AY, MA, AX, BY. 4, right? Okay, let's say we know this value. Let's say we know BY is equivalent to 70, for example. Can we solve this remaining 3? Yang ni,
Yes.
yang ni buang BY ni letak 70. So boleh tak
Boleh.
calculate remaining 3? Boleh kan?
Boleh.
Boleh kan? So the idea is this. Redundant to problem. So problem kena solve dulu. In order to achieve your aim, you have to solve problem. If you cannot solve problem, you cannot achieve your aim. Okay, so you have to have that imagination. So you have to understand that, okay, I use flexibility method whenever I cannot use equilibrium equation to solve for the reaction. Okay, so what is the problem? The problem is due to redundant. So what we need to do with redundant? Nak buat apa dengan redundant ni? Redundant ni we have to solve redundant, solve using what we call it as compatibility equation. Compatibility equation. Okay, so do you understand that bila kita this is not only applied to this one. So in any, okay, we have the problem. So when we have the problem, tak kisahlah problem structure ke, problem hidup ke, whatever kan. Okay, problem kita problem structure. We want to analyze reaction. Okay, so apa kita punya aim? We want to calculate reaction. That is our aim. Okay, kita aim after 3 years kita nak jadi engineer. So that is our aim. Okay, so what is the problem? The problem is for beam we have redundant. We have redundant in the system. Because if we have redundant value, we can be able to solve remaining reaction using equilibrium equation as usual. So what is the method? What we need to do with redundant? We need to solve redundant using compatibility equation. And compatibility equation is actually come from what we call as principle of superposition. And compatibility equation is actually come from displacement. Okay? Come from displacement. This is come from displacement. Is actually displacement equation actually. Displacement equation. Okay, and of course there is a general equation in order to understand that. Okay, later on. Okay, so kita tengok next one. Ni dah tadi. Okay, this is principle of superposition. This is just the concept. For example, okay, we have the first diagram tu. Okay, P, the first diagram is P, and then we have P1 and P2. So the idea is P from actual, so this is diagram number 1, diagram number 1 yang ni, silap. Diagram number 1 ni, diagram number 2 yang ni diagram number 0. Okay. Okay, to get P, we need to plus P1 plus P2. Okay, so that is the idea of principle of superposition, where in order to apply this principle, there are 2 requirements to be fulfilled. Okay, number one, the material must behave in linear elastic manner so that Hooke's law is valid. Tapi you have done a lab on this, right, in diploma. Are you coming from diploma or matriculation? Are you coming from diploma or matriculation?
Diploma.
Diploma. So have you heard about Hooke's law? Hooke's law, tahu tak Hooke's law?
Lupa doktor. Tahu tapi lupa.
Do you remember ada satu lab masa you belajar masa diploma dulu yang nama dia tensile test, remember?
Ingat.
Kan, tensile test yang guna UTM machine. Ada tak pakai UTM machine untuk and then from UTM machine tu you akan dapat satu graph. Okay, satu graph wherever machine tu dia akan apa? Dia
Tarik
akan,
sampai full lah.
yes, dia akan tarik sampai dia patah kan. And at the same time dia link kepada satu komputer, komputer tu akan plot satu graph. Kan? So eksperimen tu actually untuk you understand this principle Hooke's law. Okay, dia elastic manner, so must behave in elastic manner so that Hooke's law is valid. Okay, so yang kita buat in structural analysis ni semua analisis yang kita buat under determinate structure or indeterminate structure, under structural analysis ni actually fulfill Hooke's law ni. Bila fulfill Hooke's law ni baru boleh calculate reaction using equilibrium equation. Equilibrium equation tu valid bila kita apply Hooke's law. Because in real condition, actually banyak uncertainties. Okay, so when we calculate reactions using equilibrium equation, actually kita dah assume all material that we analyze actually fulfill Hooke's law ni. Dekat Hooke's law tu dia ada satu point yang nama dia yield point, remember? Yield point, whenever the material start deform, start ubah bentuk, dia ada yield point. Okay, so requirement number 2, geometry of the structure must not undergo significant change when the loads are applied. Okay, so principle of superposition ni, principle of superposition ni not only apply in this flexibility method, it is actually one of the principle well known for engineering. Okay, we will apply as well this principle of superposition in moment distribution method topics. And also we principle of superposition not only apply under structural analysis, it may be applied to other type other division. Okay, under civil engineering. Okay, so let's move. Okay, so number 1, equation of equilibrium. Equation of equilibrium, the 3 equation that we always use to analyze reaction in determinate structure. It is actually, we use the same equation in order to determine the internal forces in the system. Okay, dah 3 lebih dah, tak apa, saya move je next one. Okay, so the concept of flexibility method is actually we want to remove redundant. We want to solve the problem. The problem is due to redundant. We want to solve the problem because we know that whenever we know the value of redundant, we can solve the remaining reaction. So the problem is redundant. So what we need to do is we need to remove restraint. The redundant is the restraint and we need to remove restraint because whenever we remove restraint from the system, from the structure, from indeterminate beam, the beam will become statically determinate. Statically determinate. It is 4. It is 4. Just now it is 4 like this. it is for 1, 2, 3, and 4. Okay, 1, 2, 3, and 4. It is 4. Okay, if we, for example, remove 1. Okay, remove 1. So what happened? It will become statically determinate, right? Remove enough restraint means remove redundant. In original condition, we have roller here. And roller ada reaction by. Remove enough restraint means remove this roller. This is actually the concept. Okay? Is it okay?
Okay,
Okay.
Doktor.
Betul.
Okay. So the one that we remove, okay, the beam after removing redundant is called as primary structure. Okay, the beam after removing redundant is called as primary structure. Primary structure. This is the primary structure. Okay, primary structure. This is one of the primary structure, one possibility. Because when we have this, okay, if we remove moment, it is just like what? If we remove moment. Tadi remove BY, right? Now I remove moment. What happened to the beam? Tadi jadi cantilever. Tadi jadi cantilever when I remove BY.
Pin support.
And now I remove MA and it will become,
Pin support.
it is the name of, okay, fix remove moment jadi pin. It is correct. And the name of the type of beam is simply supported. Isn't it? Simply supported beam kan?
Betul.
Yeah.
Okay, so this is actually the two possibility. The two possibility of means that redundant ni dia ada two possibility. Either we want to have BY as redundant or MA as redundant. These two only. Of course, we cannot simply remove AY or AX. Because when we remove AX, there will be no support representing it. Okay, same goes to AX. So whenever we want to remove, okay, we have to go to look at the support. So support ni dia ada dia punya condition. Okay, fixed there are 3. So whenever we want to remove one from fixed, we have to remove moment. So that when we remove moment, it become pin. Okay, and for pin support, if we want to remove one from pin, we have to make sure that pin become roller. Okay, so there are two possibility, whether it is cantilever beam or simply supported beam, and this is actually the primary structure. Okay, the primary structure. And number 2 is redundant structure. Redundant structure. Okay, what is actually redundant structure? Redundant structure is actually the same type of beam subjected to different type of loading. Okay, and then we have to have the compatibility equation, which is come from the principle of superposition. Okay, force displacement equation relate with this. P, bila you pernah belajar ni? Bila pernah jumpa yang ni? Last semester ada ni. Do you remember? Do you still remember? Topik apa ni you jumpa benda ni?
Beam.
Okay, beam to calculate what?
Displacement.
Yes, displacement. displacement, means virtual work method. You have okay, actually learn about this under virtual work method or principle of virtual or unit load method. Okay, virtual work method, because in order to determine deflection or displacement, you have to apply a unit force, remember? Do you remember? If you do, for example, you want to calculate okay, question is calculate deflection at C. Using using unit load method or virtual work method, calculate deflection at C. What did you do in order to calculate deflection at C? Cepat, what did you do? You will apply
Unit load.
unit load. Unit load. Kenapa tak apply unit moment? Why you don't apply unit moment? Kalau you nak calculate delta C, kenapa? Kalau nak calculate theta at C, you apply apa? Yang ni? Apply apa? Apply apa ni? Do you remember this?
Moment equation.
Yang ni apa? Real system. Remember? Real system? Betul tak? Betul tak bila nak cari deflection delta at C, you have to apply a unit force. Yang ni. Number one ni, number one. Betul tak? Ini number one kan?
Betul.
Number two, when you want to calculate rotation, number two yang ni kan?
Betul.
Okay, so what is actually all this all about? It is actually force, we fulfill the force displacement principle. P force is for, delta is for P. Okay, delta is for P. Deflection, vertical deflection, horizontal deflection is for P. Force, a unit load. Okay, unit load. And when we want to calculate deflection, rotation or slope, we have to apply a unit moment. So moment dengan theta. Okay, moment theta, we call it as moment curvature. Nanti akan jumpa lah. Ini nama dia moment curvature. Tak payah ingat pun pasal moment curvature ni. Cuma yang you kena ingat, bila dia rotation, dia mesti dengan moment. Rotation mesti dengan moment. P dengan delta ni, nama dia P delta. P delta. Dia sebut terus P delta tu. Dia sebut P delta. P delta effect. Dia sebut terus macam ni. Okay? So kena ingat partner ni P dengan theta. P ni representing load lah, whether it is vertical load or horizontal load. Lepas tu kalau rotation for moment. For moment. Means that deflection, force induce deflection, moment induce rotation. Okay, so next. Okay, we move to indeterminate beams with first degree of indeterminacy or single degree of indeterminacy. So of course, as I mentioned, limit degree of indeterminacy that can be analyzed using flexibility method is up to 3, because degree of indeterminacy ni number of degree of indeterminacy ni akan reflect number of equation, number of compatibility equation. So one means one equation. Equation apa ni? Compatibility equation. Compatibility equation. Okay, so two equation. We solve using simultaneous equation with two unknown using calculator. 3 means 3 equation. Okay, 3 equation using calculator. We can have x, y, and z. That's why whenever degree of freedom is more than 3, okay, we cannot solve manually. Okay, we cannot solve manually. We must move to the stiffness method. Okay, so let's look at this beam. Okay, this beam is an indeterminate beam. 10 meter long. B ni roller This is roller support. Okay, there is a uniformly distributed load. Okay, 10 kilonewton per meter. Okay, so I want to actually we now dah 3:45. So nanti video ni saya akan continue. I will make another video to complete this example. Okay, in order to analyze this beam. So what most important here is number 1, select redundant. Select redundant by looking at this. Okay, there are 4. 1, 2, 3, 4. So 4 unknown reaction and 3 equilibrium equations. So here degree of indeterminacy is 4 minus 3 is equivalent to 1. And we have to choose redundant. Choose redundant. Redundant ni let's say R. So let's say we choose BY as redundant. Means that whenever we choose BY as redundant, we need to remove roller. So it will become this cantilever beam. So it will become cantilever beam. So this is cantilever beam as the primary beam. Okay. Okay, what is actually primary beam? So now I have removed BY here. Okay, the beam is actually cantilever beam. Okay, primary beam means we remove appropriate reaction. Okay, R. Okay, R is the redundant from original. Yang tadi yang 4 tu kita remove 1. Okay, resulting beam which is stable and determinate. So this is actually determinate. This is determinate beam. Okay, what type of beam? Cantilever beam. Of course, we have another one, simply supported beam if we remove MA from the system. Okay, then deflection at the redundant position is calculated. So by removing BY, if we look at to the deflection at position B, we will get this. Deflection. So nampak tak relation tu? Kenapa kena tahu reaction? Lepas reaction internal forces, lepas tu deflection. So kita akan apply all these 3, okay, 3 things ni yang you have learned previously ni. Kita akan apply all these 3 principle knowledge under the flexibility method in order to solve for the redundant value. Kena apply semua sekali. Okay, kalau mana-mana part tu yang tak boleh solve, means that you tak boleh solve sampai habis. Okay, in order to solve for the redundant, you have to analyze reaction, analyze internal forces and then determine displacement. Barulah boleh dapat redundant value. So dah lepas kita dah remove all the redundant, we have to draw the shape, the deflected shape, and then please look at to the redundant position. Redundant position means dekat B tu is redundant position, and mark the deflection at B. The deflection at B is here is delta B naught. Okay, delta B naught, deflection at position B. So delta B naught ni is called as deflection. Okay, deflection delta B naught ni is deflection at B, sebab B tu redundant position, for primary beam. So primary beam simbol dia ada naught tu. So delta B naught ni ada simbol naught ni, delta B naught. Okay, the first notation is for the position, the second notation is for type of beam. You have to remember this. This is very, very important. Okay, the first notation is for the redundant position. Redundant position, position dia dekat B. And the second notation is for the what? Type of beam. Type dia ni lah. Primary beam. Okay, so next. Okay, kita tengok what are the characteristic of primary beams. Number 1, only external loading apply on it. Kita tengok balik. We remain external loading. We remain external loading. Number 2, redundant BY has been removed. Redundant BY has been removed. Ada tak BY dekat situ? Ada tak BY?
Tak ada.
Tak ada BY. We have removed. Okay. Number 3, sketch a deflected shape of the beam. Lepas dah remove, draw deflected shape. So kita dah draw deflected shape. Okay. So dia jadi cantilever. Cantilever beam. And then cantilever beam dia ada deflection. Okay, deflection at B. Deflection at B we mark as delta B naught. What is the meaning of B and naught? B, the first notation is for the redundant position. Position is at B, and naught is for the type of beam. For type of beam. So this is primary beam. So symbol naught itself too is for type of beam. Okay, then if the force is to be determined, tadi kan force ni P. And tadi kan delta, right? Delta B naught, remember? Delta B naught. Nampak tak kita sedang fulfill force displacement principle. P and delta. Okay, if the force is to be determined, then apply deflection. Kalau moment is to be determined, apply rotation. Do you get that? Do you get that?
Yes, Doctor.
Okay. Delta B naught denotes deflection at NB or position B. Position B. The deflection is shown. The deflection is shown at the point of application and in the direction of the redundant. Okay, the direction of the redundant. Okay, kita tengok redundant beam. Redundant beam. Okay, redundant beam dia akan apply, okay. If the primary beam is cantilever beam, redundant also cantilever beam. If primary beam is simply supported beam, redundant beam also simply supported beam. And in this case, primary beam is cantilever beam, so redundant beam is cantilever beam. Okay, so what is actually redundant beam? Okay, in redundant beam, we need to remove all external load. We need to remove all external load. So what we apply here is actually we apply back BY. We apply back BY. Dia macam ni tau. The idea is like this. Okay, based on the principle of superposition, okay, we have actual like this. This is actual. Okay, primary beam. We remove redundant. Okay, plus cantilever beam. We apply back BY. Because in actual beam, there are 4, including BY. And after removing redundant BY from primary system, so here is 0 plus BY. So we get back BY here. Do you get that? BY is equal to 0 plus BY. This is the principle of superposition. BY is equal to 0 plus BY. And then this is 10 kilonewton per meter external load, right? So this 10 kilonewton per meter external load is equal to 10 kilonewton plus 0. So we get back to this, we get back to this, and get back to this. Okay, this is the idea of principle of superposition. So we have 2 systems to be analyzed. Number 1, yang ni. Okay, it is primary beam. Number 2 is this. Okay, primary beam. This is primary beam. And what we call? Redundant beam. And to be specific, we apply BY as an applied load. We don't put roller back. We apply. This is principle. Okay, we apply BY as an applied load into the cantilever beam. So to be specific, it is redundant BY applied. Kejap. Kita tutup pula. Kejap. Okay. So do you get the idea of this principle of superposition? So this idea is very important. Applied. Okay, the idea of principle of superposition is like this. Okay, so I want to stop lesson for today. So please try to understand. Okay, do some revision and try to understand what you have learned today. And I will complete this in another video, and I will upload and put the link in the Teams. Okay, so dah pukul 4. So can we all, before we stop the session today, okay, can everyone, okay, switch on camera for the photo session for today? Okay, please switch on camera. Before we end session today, so okay, come quickly. I don't have time to call your name one by one. So dah pukul 4. Okay, cepat. Nak snap picture? Okay, start. Okay, 1, 2, 3. Okay, another one. Another one. Okay. 1, 2, 3. Okay. Okay. 1, 2, 3. Okay. Okay, thank you very much. We will close our session by Tasbih Kifarah and Surah Wal As. Okay, thank you. We meet again insyaAllah in the next class. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, Doctor.
Thank you, Dr. Sri.
Thank you, Doctor.
Okay.